Hello guys, we'll be starting in a few moments. Hello guys, welcome to the event. Thank you all for joining. It's been a wonderful experience having you on board. So let's start off with the event. I'm sorry it was a long wait. What are we going to study today? But before that, let me introduce myself. Hello, I'm Sabyasachi. I'm a Gold Microsoft Student Ambassador at Microsoft. I've been Azure certified 4 times, and you can reach me at sabyasachi.seal@studentambassadors.com. So this is what we are going to study today. It is about local to global, how to host your app using Azure virtual machines, NGINX, and GitHub. So let's get right into it. Well, firstly, before starting off, I would like to cover what scenarios are we going to cover. Firstly, we're going to see how to use private repos with Azure virtual machines. We're going to see how to use public repos with Azure virtual machines. We are going to see how to use load balancers. And at the end, we are also going to see how do we use web servers. Don't worry, these are very big words. If you don't know about virtual machines, private repos, public repos, or load balancers and web servers, I'm here to teach you all about them. Well, let's get started. So starting off with the basics, what are Azure virtual machines? Well, what does it sound like? Virtual and the word machine together. Azure is the cloud platform provided by Microsoft. What is virtual machine? Machine is literally something that does computations. What does a virtual machine mean? Does it mean that the machine does not really exist? Does it mean that the machine is not really with you? Well, if you did guess both of them, I would say you're kind of right. Azure virtual machines are computational platforms on the cloud that you can control remotely, which in simple terms means that they are machines that are not with you, but they are in your control. This is a more detailed explanation for Azure virtual machines. Um, so what are Azure virtual machines? If you go through them, they are on-demand scalable computing resources. What is on-demand? What is scalable? I'm going to explain all these words to you. Provided by Microsoft Azure, the cloud computing platform and services offered by Microsoft. So Azure is cloud computing platform and services offered by Microsoft. Why do we use virtual machines? Well, before that, let's talk about Azure virtual machines. Why do we use Azure virtual machines? We use them to deploy, manage virtualized Windows, and Linux servers in the cloud, providing flexibility, scalability, reliability for hosting our applications. Now, I'm going to let that sink in for a moment while you think about it. That why are we using virtual machines, and go about the terms again. I hope that time was enough. So let's start off with each word one by one. Let's talk about scalability. What is scalability? Well, in simple terms, think about scalability as the fact that you can make something bigger and better, and then when you don't require it, you can put it back to its old configuration. Think it in terms of a expanding bottle. If you put in more water, then the bottle becomes bigger. If you drink all the water, then the bottle becomes smaller. That's the simplest way of putting scalability into use. Well, coming to the bookish terms, Azure virtual machines allow you to scale your computing resources up or down. You see, scaling up or scaling down on demand, ensuring that your application can handle fluctuations in the traffic without downtime. So, in our case, the bottle is the machine and the water is the traffic. So when there's more traffic, our bottle becomes bigger. That is, our machine scales up or our bottle becomes bigger, as in the computing power of the machine increases. And at the same time, when the machine scales down, that is, the water is no longer in the bottle, then the bottle can become smaller because it doesn't need to hold that much of water, or in other terms, it does not need to handle those much of traffic fluctuations. Well, that's it for scalability. Let's talk about flexibility. What is flexibility? It means that I can choose whatever I want. If today I want to use something like Linux to go around with, I can choose that. If I want Windows, I can do that. So that's the amount of flexibility that you get. You can also have flexibility around other things like how much CPUs do I need, how much RAM do I need, how much storage do I need. I mean, different apps and different workloads will always have different amounts of requirements, right? So this flexibility helps through that. So with Azure VMs, you can basically have flexibility to choose from a wide range of VM sizes, operating systems, and configurations, allowing you to tailor to the resources to meet specific requirements of your application, which in simple terms again means as per your application needs, you can have flexible outcomes of the machine. Suppose, let's say you have a very big app that you want to deploy, then you can happily happily allocate more storage to your virtual machine. If your app is rather small, but you know that it's going to need a lot of computing power, then maybe keep the storage small, but have a bigger CPU in it. That way, you're actually having the flexibility of choosing whatever, whenever, and however you want. Let's talk about high availability. Well, availability basically tells you how available my system is. To put it simply, if someone's busy, right? If you talk to someone and they are busy, or if you want to talk to someone and they're not really available, that's when we say that his availability is low. The same term, this can be put in the cloud. If some service is always available, it's always available to you, that means any time of the day, any time of the week, at any part of the world, if you can access it without any problems, then it's highly available. If there are restrictions, for example, it's not present in some countries. For example, it is only present from 12 p.m. to 10 p.m. 12 p.m. to 10 a.m. I mean, then it's low availability relatively. So I guess you understand what availability right now means. So Azure offers built-in features such as availability, sets availability zones. I'll tell you what that is. Helps you ensure high availability and fault tolerance of your applications by distributing VM instances across multiple physical servers and data centers. So basically, availability zones is a place where I can say my application will be available. Azure offers you multiple availability zones. So what happens if one zone goes down? My app is present in the other zone as well. So that is how you use multiple availability zones to ensure high availability with fault tolerance. Fault tolerance is the fact that if one of the data centers or availability zones go down, you have something else to keep it on with. That's availability zones. And how does it actually handle so many availability zones? It's distributed the VM instances across multiple physical servers and data centers. So ultimately, like I said, a virtual machine is actually a machine present somewhere in the world. It's just not with you. You're accessing it remotely. which means that the virtual machine is somewhere present in physical form. What does Azure do? It places these physical machines, I'm sorry, across a lot of different globally isolated places. So let's talk about security. When you talk about remote access, right? The first thing that comes into your mind is if I can access it, in terms of security, at least, if you can access it, then somebody else can access it also, and that too remotely. That is a problem. That's why security comes into place. That's why security is so important here. So Azure provides you robust security features like firewalls. Definitely, firewalls is something needed. Network security groups, encryption and rest at rest and in transit, identity and access management controls, helping you protect your applications from data and threats. So what's basically happening here is firewalls are uh, you can call them as different filtering devices or filtering software, which will basically allow only certain number of applications and ports and different network configurations to go through. Network security groups are a group of these different firewalls and other settings. Encryption is the fact that if I have a data, then somebody in between me and my receiver should not be able to understand that data. That is where you use encryption. At rest is indicating that encryption is done when your data is not moving, that is, it's just stored in your files. And in transit, that means when you're transferring your files from region A to region B or place A to place B or person A to person B, then also your data is fully encrypted. Identity and access management basically helps with authorization and authentication. So these two are more related with the fact that who is controlling all the stuff. And at the end, it helps you protect your applications and data from threats using all these. And last but not the least, and I will say one of the most important, is cost effectiveness. You see, these remote servers come with a cost. Accessing a remote server, basically carrying a good computer in your pocket, does cost something, right? If I can log into a browser and have access to some sort of service, then that does come with a cost. And the cost in our case is Azure's models, pricing models. But Azure has a very interesting way of giving us the pricing. We only pay for what we use. So normally you see, what do we do when we buy a computer? We usually just go to a store, pay the price, and then just buy it, have it for a year, 2, 3, or whatever time. In our case, Azure actually only charges us for the time we use it. So comparing side to side, if we talk about virtual machines and physical machines, then on terms of virtual machines, we have a pay as you grow pricing, which means if I use it for 5 hours in total, then I'm going to pay for that 5 hours. But in physical, I have to pay for the entire hardware. I have to pay for everything. Then only I can use the 5 hours. Doesn't matter if I'm going to use it 5 hours, 5 years, 5 days, or whatever. I have to pay the full price. That's a major disadvantage when you want to experiment up and down and want to host your app, uh, especially with cost effectiveness in mind. So it only makes us pay for the resources we use with no upfront cost. So I don't have to pay anything first and then use it, all long-term commitments. So it's not like I have to use it for 1 year or 2 years, something like that. Additionally, Azure provides cost management tools and options for reserved instances. Reserved instances are instances that you will get. It's not that it's not available or something, but it's reserved for you. Help optimize your cloud spending. Okay. So I hope that was a good enough introduction for Azure virtual machines. Let's move on. There are different types of virtual machines when we talk about virtual machines. So I think we all talked about the fact that virtual machines are here to have flexibility, right? This also kind of falls into the flexibility manner. So it can basically let you decide what sort of virtual machine you want. You can have general purpose machines compute optimized, memory optimized, and storage optimized. All of these have a different use case, I would say. General purpose are more for a wide range of workloads, as it says here. So this basically includes your small web servers, databases, development test environments. This is mostly used for small apps, and otherwise, if you don't know what pricing models or what prices you're going to incur, then general purpose is the best way to go. Otherwise, if you're just trying to test out Azure and do certain stuff, then I would say general purpose is the way to go ahead. Otherwise, you have also things like compute optimized. So compute optimized are designed for compute intensive workloads. These are really along the sides of ML and DL, all those stuff. So compute optimized are mainly used in places where computational power is at the dire need. So let's say even if you're calculating a lot of stuff, if you're doing some ML algorithms, right? They do a lot of maths in the background. So compute optimized VMs will do those things faster. And who doesn't want to save time? So these are high performance computing, batch processing, and gaming applications, right? Then we come to memory optimized. Memory optimized is usually used when you're trying to deploy a lot of containers or maybe a lot of distributed things inside the virtual machine, right? So this is also used for a lot of analytics works because it requires a lot of memory in the background. Alongside, when we talk analytics, it has to be for databases, right? So databases are also included in this. So you see, it's ideal for memory intensive workloads such as relational databases, big data analytics, and in-memory caching. So storage optimized VMs, this is kind of a place where nobody really talks about, but storage optimized can be combined with these three as well. So you can have a different storage selected for these three, but storage optimized are basically VMs where you have a high input output speed. So basically what happens is input output speed is always defined when you try to make a virtual machine. You can select different ones, but storage optimized VMs have the speciality of having high input output speeds. So these can range from 7 gigabytes per second to something maybe even tens of gigabytes per second. So so these are storage intensive workloads such as large databases. So if you're running production or maybe you're transferring a lot of data per minute, so this is what you should go for. Data warehousing. Also, warehousing is different from analytics. Warehousing is more of storage and analytics is more of analyzing. And high throughput transactional applications. So if you're trying to calculate a lot of things and provide it to some output or API or anything at all, then storage optimized is the way to go. Always remember, um, Azure provides you a detailed list of what should be the cost, what should be forecasted cost, what should be the predicted cost, and all these things inside your subscriptions. If you also want to go for the other things like the other types of VMs, you can have a look at their list of VMs that there are. That will help you get through it. So let's talk about load balancing, right? I wanted to talk about load balancing because load balancing is something that we will have as a part of our virtual machines only. So it is a process of distributing incoming network traffic across multiple servers or resources to ensure no single component is overwhelmed, thereby enhancing reliability and maximizing performance. So imagine two users, right? User one, user two, both requesting a machine M. So this goes here, this goes here. Machine M has to return the sum of two numbers, right? Now, one asks it, so it's like, hey, give me this one first. Two asks it, is like, hey, give me this one first. It will have to stop one and give it to another and then give it to the next one. It'll either have to give to one first, then give it to two, or it'll have to give it to two first, then give it to one. This shouldn't happen, right? This is where load balancers come in. What happens is, in our case, you see one and two both have the same link, right? So two people should not have different links. So if I have two machines to distribute this workload, then a load balancer, let's say M, will basically connect these two machines, give a single link, and this will be person 1, this will be person 2, and they will basically put their requests here. Load balancer will send the first request to this, load balancer will send the second request to this, and this is how they get back the response. So that's what is basically described here. So it distributes incoming network traffic across multiple servers. So these are multiple servers, and this is the distribution. You see, to ensure no single component is overwhelmed. So in our case, what was happening? One single component was getting overwhelmed, thereby enhancing reliability and maximizing performance. So the thing is that availability, reliability, and optimal performance is paramount for all business sizes, right? If you don't have these three things, then whatever you're hosting and making, there is just no guarantee that that thing is going to stay up for a long time, right? So an application workload increases, so the efficient traffic distribution is necessary, and also resource utilization increases. So that is also necessary to take into consideration. This is where load balancers help us. It's handling a surge in website visitors or managing requests to a database application. Effective load balancing is the backbone of modern infrastructure, right? So that was about load balancing. There is a very specific load balancer that I want to teach you about. That is Azure's load balancer. But I guess we have types of load balancing. We are going to go through quickly. So load balancing can be public, right? So public load balancing basically has websites with high traffic. It has public facing APIs. Oh, sorry, that one looks weird. Right. So web applications with high traffic, public facing APIs, content delivery networks, multi-tier web architectures, global application distribution. So anything that is going to the users or going to your end consumer should be used with public, right? So that's why there is web applications with high traffic, public facing APIs, content delivery networks, multi-tier web architectures, global application distribution. Okay. Just give me a second. I'll check if I've turned on the recording. Yep, recording is turned on. That's all I wanted to check. Yeah, let's come back to this. So there is internal load balancing also. So what do we use internal for? It's definitely not going to the users. So it's backend services. That's why it's backend services with a virtual net. Database clusters, because that's also in the backend. We don't really show our databases to the users. Internal APIs, communication between virtual machines, and private application access. So you see, all of this that is mentioned here, this is nothing to do with the user. This is everything that is happening internally, right? If I have an application and I get a link, suppose x.x.com, something, something, then this internal load balancer will never be a primary source of contact with those with that external IP. There has to be something else which will do that, because the internal one is actually load balancing between the internal services. The public one is load balancing between the public services. So you might say, if I want to do both, then what happens? Good question. That's where hybrid one comes in, right? Did you see that coming? So what do we use it for? We use it for on-premises to cloud migration. On-premises means if you have your machines on your own house or your office, then if you try to get that to the cloud, then what do you have to do? That is hybrid. Multi-site application deployments. So yeah, that helps through. And secure communication challenge. Yeah, yep, that was it. Now let's talk about Azure load balancing. Now load balancing is a very complex task between VMs. So Azure Load Balancer is something that makes this task very, 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 very easy by actually providing you a good interface and a lot of features that you can normally just implement that would take hours and hours to implement manually. So let's talk about Azure Load Balancer. Why is it simple? Azure Load Balancer is a highly scalable. We did talk about highly available, sorry, highly available and scalable. So both of them. We did talk about availability and scalability back in the first or second slide, I believe. It's a highly available and scalable layer 4, that is TCP and UDP load balancer provided Microsoft by Microsoft Azure, right? So Azure Load Balancer is basically a load balancer which is available highly and scalable on its own. So imagine if a lot of people start requesting the load balancer itself, it is distributing traffic, but it is also doing some sort of a computation inside, right? To say that, okay, this traffic goes to that machine, this traffic goes to this machine. So if the number of users are so high that the load balancer also starts to slow down, that's where Azure load balancer comes in. It is highly available. That is, it can be deployed in multiple regions. Alongside that, it is highly scalable. So if users increase, this also increases its computing power. No issues. So Azure Load Balancer is a highly available and scalable layer 4 TCP UDP load balancer provided by Microsoft Azure. It distributes incoming traffic across multiple VM instances to ensure high availability and reliability of applications. Well, I really like the diagram here. I got this from Microsoft Learn itself. So let's talk about the diagram. So you can see the public load balancer, right? Consider this as users. Forgive my handwriting. This is the users. This is the public load balancer. See, the public load balancer is always going to help the users. And we have an internal load balancer. The internal load balancer is never directly connected with the users. So you see, this is actually load balancing between the VMs. Whatever is going here, this VM is requesting something and it's saying, okay, you want to get some sort of data, let me send it to this. This is requesting, it's sending to this. This is requesting, it's sending to this. So it's internally load balancing, but it is never going to the users directly. Look at the public load balancer. Whenever this gets back the data from any of this, and the public and some request some user requests something, so it's like, okay, this has the data. Let us give that back to you, right? So you see, if we use load balancing like this, it is so much more efficient than actually using this one machine and doing everything there, because we are literally distributing our workload, right? And if you look at the whole box here that is outlined, the dotted box, that's what a hybrid load balancer looks like. It's doing both the things. It's giving something to the users, alongside it is making an internal load balancing act itself. Okay, that is Azure load balancer. So there are many reasons why to use the Azure load balancer. Again, highly availability, so continuous availability of applications by distributing traffic across multiple backend instances. This we talked about. And this is the important one. Automatically detects and reroutes traffic from unhealthy instances, minimizing downtime. So unhealthy instances are instances basically which are not working in your way. So if it detects that something is unhealthy, it will not send any request there. It will not give any wrong answer. Scalability scales application resources dynamically to handle for fluctuating workloads. We talked about this. It is easily adds or removes backend instances without impacting service availability. So the Azure Load Balancer has a great thing that it can add virtual machines itself. You don't need to physically tell it that, hey, add this many virtual machines or add this many, or go and add yourself and then add it to the load balancer, because that is a hell lot of task. What Azure Load Balancer can do is basically let you add and remove instances very easily without actually putting any headache on your side. So in this case, imagine if suddenly my workload increases or decreases, doesn't matter. Azure Load Balancer will take care of it. You can be rest assured that your cost that comes at the end of the day is always the most optimized, because Azure Load Balancer increased or decreased the amount of instances according to the load. So you see, there is performance optimization, improves response times and reduces latency by directing traffic to the nearest and healthiest backend instances, right? So suppose you're from Europe and there is a machine in Europe only that is in a load balancer, but there are different machines across different places of the world. So the load balancer will detect that you're from Europe and the closest machine to you is in Europe only. So it will direct your traffic to the Europe machine. So that is how it improves the response times and reduces latency. Response time is basically the inverse of latency. And it directs traffic to the nearest and healthiest instances. It distributes incoming requests evenly, preventing overload of individual resources. We talked about this. So if there are multiple requests that are coming. It will distribute that traffic and basically not let any of the one machines get overwhelmed. So we talked about cost efficiency. So it optimizes resource utilization by evenly distributing traffic, reducing the need for over provisioning. Okay. So you only pay for the resources that are consumed with built-in scalability to adapt to changing demands. So as per your traffic, the number of virtual machines increase or decrease. So you only pay for what is actually required, what was actually required in your whole month, right? And this is one of the most important. It's simplified management, right? So you see, when you open the load balancer, you'll basically see a lot of stuff like different text that you can include and different policies that you can have. The thing is that if you try to make this manually, I'll show you where to make this manually, but it is a lot of work to get that done. So that's what Azure Load Balancer actually wins in every situation. It's so easy to configure that. And it offers built-in monitoring and diagnostic tools for proactive performance and optimization and troubleshooting, right? So it can help you monitor, diagnose, and optimize, right? So you can monitor all the machines, you can diagnose if there's any problem, you can optimize their usage. Like this is all happening from a UI. Normally, what would you have to do? You would have to go in each of the machines and check, okay, this is working in this way, that is working in this way. Like that is a lot of task, lot of time will be taken in that. So last one is secure communication, that is facilitates secure communication between clients and backend services through built-in SSL termination and encryption capabilities. So there is no HTTP, simple HTTP policies. It's fully managed secure communication by SSL. So now let's talk about NGINX. What is NGINX? NGINX is a web server, firstly. It is a high performance open source web server. So when you see the word open source, it means free, reverse proxy, and load balancer. So I would say don't use Nginx for load balancing. It's a wrong practice. Rather use something like Azure Load Balancer. But you should use it as a web server and reverse proxy. It is renowned for efficiently handling high traffic, delivering content quickly, enhancing performance, reliability, and security of the web applications. So let's talk about why we use Nginx. So of course, firstly, high performance. Nginx is literally one of the best web servers that is available right now. It is being used in the industry for, I guess, the last 10 years. And Nginx efficiently handles thousands of concurrent connections, delivering static and dynamic content swiftly. That means it literally reroutes your traffic very efficiently. That's what it means. Reverse proxy, again, new word alert, new word alert. It means that it basically reroutes your traffic to something else. So suppose, let's say I go to abc.com slash new site, that will go to one set of servers. And if I go to slash old site, that would go to another set of servers. So that is what a reverse proxy is known as. The fact that I can use the path of the URL and reroute my traffic is reverse proxy, right? It uses reverse proxy server, improving security, scalability, and performance by offloading tasks like SSL termination and load balancing. So of course, it has caching as well. So it has powerful caching features like reduce load on backend servers and enhanced responsiveness. So caching is basically a practice in regular day-to-day work where we try to store stuff that have not been changed, right? So basically what happens is if in some case some data is changed, but the rest of the data is same, caching will basically help us to only load the data that has changed. Because if we try to load everything from scratch again, then the issue is that the response time will be very high and the latency will be very low. I mean, latency will be very high, right? So caching basically helps us prevent that. Okay. SSL and TLS offloading. So again, SSL and TLS. So TLS means transfer level security and SSL means secure socket layer. So This basically helps in encryption. So there is no sort of security issue when it comes to your reverse proxy. And since it's offloading, that's why it's improving performance and reducing backend server load. The security, it has access control, rate limiting, protection against common web vulnerabilities. So it can actually rate limit you, right? So if you try to request a lot of things in maybe a second or maybe 2 seconds, then the issue that will occur is the backend servers might not be able to handle it. But in the same time, you don't want your servers to go down. So what happens is this one will help you rate limit. So suppose you can define something like you can only make 100 requests in 1 second. So in that way, you always know that if somebody, the 101st request will actually be dropped off. So it will tell you that, hey, you can try after 5 seconds, it will work, right? So in this way, the fact that your server performs efficiently is continued and enhanced. So it can also provide performance optimization, like NGINX serves static content efficiently and reduces latency. Static content usually means stuff that is already there. Nothing is being generated. So front-end websites are usually built to make a static content. So that is static. The security is again, I guess this is just a copy point. Forget about this. So let's look at this. This looks like a very weird server block, right? It looks like a very weird thing. But let me tell you what this is. This is how to configure NGINX in Azure virtual machines. Firstly, you would need to connect to your Azure virtual machine, right? You can use SSH or RDP to access your virtual machine. Then you need to run these 3 commands. Then you can basically start NGINX and make configurations, right? I will show you how to make the most basic configuration server in NGINX and how to get it hosted, right? Well, that is not just the amount of configurations that are there that you can do in NGINX. There are so many more. So I want to show you the other configurations that are there. So you can have virtual hosts. So configure Nginx to serve multiple websites or applications by setting up virtual hosts. So Nginx can actually help you reroute a path to multiple websites in your own virtual machine. So suppose 3000 has one website, 5000 has one website. Nginx can help you get that one path among the two that will help you reroute the traffic between the two, right? There is a load balancing inside virtual, but I would say use Azure load balancer, because we just talked about this, that in a global scenario, Nginx will be staying inside a machine, but you as a person want to load balance multiple machines, right? So it is better that you use an Azure load balancer here so that you can use multiple machines. Let Nginx be on each of these machines, but use an Azure load balancer so that it can load balance between these two. So we have already talked about caching. We can configure this caching inside Nginx to cache static and dynamic content to reduce latency and improve performance for frequently accessed resources. And we can have security headers. That is very important. In a production workload, we always want security to be one of the top priorities. So we can add security headers to Nginx, which will basically help protect against common web vulnerabilities and enhance security posture. Right. So this brings us to our last slide, or should I say semi-last slide, because this is where we will be learning about uh, how to actually make these virtual machines and host some stuff on them. So I hope you can see my screen. I'll go to portal.azure.com. Let's load up. You can click on these virtual machines. Like I've used all these, so all of this is here. You might not see this here. So I want you to search up virtual machines, you will see this. Well, I already have a virtual machine, but you might have this as empty. So let's create a virtual machine. Well, you have to select the first one. The other two are a little bit more presets and some things are predefined, but I want you to select the first one. After we have selected them, you will see this page. So basically you have to select a subscription first. If you don't have a subscription, then you can request for one if you're a student, or you can just subscribe to one. I think Azure gives you around $200 of free usage once you subscribe as a student, once you prove that you're a student. So you have to select a resource groups. I have some resource groups already made, but what I'm going to do is maybe select one of these resource groups that I've made. If not, you can click on create new, and this will just create a resource group for you. Well, we can name our virtual machine. I'm going to make a test machine, or maybe let's say local to global test machine. You have to select your region. If you want, you can select anything that is close to you. I'll just keep it as default. So you can select different availability zones that we discussed about. So many availability zones means much more available. So you have to select at least one. So let's select one. So now security type can be standard. You don't have to basically trusted launch virtual machines. All this stuff you have to basically use standard. This is the image. So this is basically the OS that is going to go in your virtual machine. I'm going to select Ubuntu Server 22.4 LTS. You can select anything Ubuntu. Even if you want, you can select Windows Server. Both work same. So let's see. I'm going to see all sizes. This is where you can basically select the correct VM for your needs. This will show you the cost and everything. So let's see. I'm going to choose something cheap. Mhm. So okay. Yeah. So I got something here. I'll use this one. Yeah. So this one is kind of in my budget. So I'm going to select this one. And here is where you can basically make different mm, ways of authenticating into your machine. I will select password authentication. So I have to basically select a username and password. So for username, I'm going to select Versace, and I'm going to give a password. Definitely not going to tell you guys. Right. So you don't have to really do much here. I'm going to take you through some other settings that are there. So you can see disks. So disks is basically the storage that is going to come with your virtual machine. Make sure to tick this key. Otherwise, when you delete your virtual machine, your disk doesn't get deleted. And then the thing is, it takes up your costs. So networking, you can basically keep this anywhere. I'm going to put this here, VNet, right? That looks good. And here is where you can add it to Azure load balancing, but I don't want to add it right now because I'm just going to show you NGINX. There are some different virtual machines. So you don't want auto shutdown or emailing. So that's the thing. You can turn this off. I really don't like auto shutdown because I want my servers to be available all the time. And now let's see monitoring. So you can set different alerts and diagnostics and health checks for your machine. So custom data is being basically things that are going to run before your machine starts. And there are some different extensions and user data that you can choose, but we are just going to keep it empty here. Tags, you can select tags to keep it inside, or maybe remember that you made this for this thing. This is going to keep it empty again. So this is where you review and create. So Azure right now will check out everything that you have and then just give you an estimate of what sort of cost you're looking at per month. And alongside that, all the stuff that you have. If your validation does not pass here, it means that some configuration that you did is wrong. So you should go back and check it again. So I'm going to click create. So it takes about a minute or two to make, maybe even faster sometimes. I think everybody is doing good. So here you can see the deployment, submitting deployment template for resource group GitHub apps. So that's basically our machine. So our machine is being made. It's being deployed right now. Let's see how much time does it take. Normally it takes about a minute or two, as I mentioned, but let's see. Should be done about now. Yeah, I see created. I see a lot of green text, which look good. I'll also show you how to SSH into your machine. It's a simple command. It doesn't really matter if you're on Windows or Linux because the SSH command is same both. Right. Our machine is made, so you can click go to resource and you will see our machine that is global to test, local to global test machine is ready. And this is the IP that we have got. So in order to connect your machine, first thing that you have to do is open command prompt. I'm on Windows, same command on Linux, no difference, literally no difference. You have to type SSH, then your username. My username was Sabyasachi @ then paste your IP. Sorry, paste your IP. Right. So if you press enter, now you will get this sort of a prompt that are you sure you want to continue connecting? You have to type yes. This is where it's going to ask for your password and you're going to give your password. Let's hope that I remember my password correctly. And here we go. You're inside your machine. So you see, I'm inside Sabyasachi @local to global test machine. Okay. So first things first, you have to run sudo apt update. Should be update. It's going to update all the packages that are there. Before that, I would like to show you that here, you see, if I go to the link, nothing comes up, right? Nothing comes up. So we are going to change that. Yeah. So what we can do is basically install NGINX by running sudo apt install NGINX. You have to press Y here and then just go with it. So NGINX is currently installed. You can check the status of NGINX by basically doing sudo service NGINX status. So you see, NGINX is active and running, right? So let's go to our IP again. Let's see if we can access it. Oh no, we still can't access it. It's because we didn't do a configuration. That is, we have to allow the port 80 to be accessible. How to do that? Basically, you have to create a port rule. And here you basically say port 80 is accessible by everyone. And you have to add that. And I want you to create another rule, which will basically say that anything outside my that is coming outside of my machine should be accessible. So outbound connections are connections that go outside of your machine, and inbound connections are the connections that come in your machine. So I've added these two. Let's see if they were successful. Looks like that. And let's reload this page, reload this page. Hopefully it should come up anytime now. By that time, I will just show you where the NGINX configuration files are actually located. So as you see, if I go to cd/nginx, sorry, cd/etc/nginx, then if I go to cd sites available, then I have a default. So let's do sudo vim default. So I showed you this sort of a configuration in the code itself. So this is the code that is running to basically show you all this stuff that is going to happen in a few moments. Let's see if our website is up. Yeah, you see. So our IP is basically giving us this. So our IP that we just made, you see this IP, public IP address. Click here and paste it on here. You see, welcome to NGINX. You can again customize this page further and further. You can put this different HTML. You can proxy pass it to a different site. There is a lot more things that you can do with it, right? This was a basic test to show basic way to make a NGINX on a VM, right? So that was our hands-on session. Now let's end this session with this beautiful document that Microsoft has created. It's on Microsoft Learn. It's in the era of Azure virtual machines. It will tell you a lot about Azure virtual machines, and if you want to learn and do some things on virtual machines, then this will teach you a lot. And thank you all for listening to me for so long and bearing my boring speeches throughout this session. I hope you have understood and learned something today. And if you have any questions, anything at all, you can hit me up on my email. I'll also send you certificates to all the participants who have attended this. And alongside that, I will send you a quiz link in the email, which you have to complete within tomorrow 12 p.m. And the top answers with the fastest fingers will be getting some Xbox Game Pass vouchers. And that was it for this session. If you want more sessions like this, you can tell me. You can hit some comments up, and I'll be more than happy to do them for you. Well, that's it. Signing out. I guess that was it for this one. Until next time, and I hope you all have a great day. Thank you.